Good morning, friends. In the first lecture, we are talking about the imaginary I of a complex number. Today we are starting here the complex number and quadratic equation with the complex number. What is the complex number and how we can write the complex number? First, I explain to you how you can write the complex number. So, if you just wanted to write down a complex number, then a complex number is written in the form of z is equal to a plus I. Z is equal to a plus iv. This is called as the complex number. I provide example in the numerical parts as a like z is equal to 2 plus 3i. This is also the complex number. Here you see that z is equal to 2 plus 3i, that is a complex number. Okay. Then here is some properties of the complex number. First property is that purely real. When a complex number is purely real, then here you see if any complex number, the imaginary part, it means that I and B, that is equal to 0. Here is written Im. Im it means imaginary. Z means complex number. Imaginary part of a complex number, if that is equal to 0, then you can say that complex number is purely real. Example, suppose that if you have complex number z that is equal to 2, it means that complex number is a purely real. You can say. Similarly, suppose that you have a complex number and that is equal to purely imaginary. At that situation, how you can represent that this is the purely imaginary? At that situation, if you are finding that his real part, any complex number real part that is equal to 0, it means RE, it means real. Z means complex number. If the real part of any complex number that is equal to 0, then you can say that complex number is imaginary complex number, purely imaginary complex number. As example, if here 2 is a 0 and there is a only part of 3iv, then you can say that complex number is purely imaginary. As example, if you have a complex number z that is equal to 3i, here the real part is not given, so you can say that complex number is a purely imaginary complex number, and it is only possible if the real part of that complex number that is equal to 0. Okay, all of you understand? I think all of you understand how we can denote a complex number. Complex number denoted in the form of z is equal to a plus iv. It is a standard form of the complex number where a is the real parts and iv is the imaginary parts. If a complex number is purely real, then that imaginary part that is equal to 0, so it is a purely real. If the real parts of that complex number it is equal to 0, then you can say that complex number is a purely imaginary. After that, we are talking about the conjugate. It is a very important part. What is the conjugate of a complex? Suppose that you have a next point that you have a complex number, then you just wanted to find the modulus of that complex number. Modulus of that complex number, it is written in the form of mod z. Suppose that you have a complex number z that is equal to a plus ib, then you write down that mod z, this is equal to under root a square plus b square. Okay. So, if you just wanted to take the modulus of the complex number, then that is equal to under root a square plus b square. Okay. After that, second conditions, that the properties of the complex number. The properties of the complex number, first condition is that if you just wanted to take the sum of two complex number, If you take the sum of two complex number, that you have a complex number Z1 that is equal to A plus IB, another complex number Z2 that is equal to C plus ID. At that situation, if you just wanted to take the sum of both complex number, that is equal to Z1 plus Z2. If you take the Z1 plus Z2, so A plus IB, this is the Z1 plus C plus ID, that is equal to Z2. Okay. If you take Z1 plus Z2, at that situation you add real part to the real parts, so that is equal to A plus C. This is the real parts, and after that you can add imaginary part I is equal to B plus D. You take the common I because these are the imaginary parts, so you add imaginary part with the imaginary parts and real part to the real part, same kinds of the situations in the form of the subtraction. Okay, so you can take that this is a Z1 plus Z2, this is a A plus IB and plus C plus ID. Then in the case of the addition, so same case in the case of subtraction. Okay, there are the some properties related to the sum of the two complex number. First property is a closure property. What is a closure property? Okay, right? Suppose that you have a two complex number. I have a two complex number, that one is a Z1 that is equal to A plus IB, another complex number Z2 that is equal to C plus ID. Okay. If you apply the closure property, it means you take sum or difference of two complex number, then the result is also a complex number. This is called as the closure property. Okay. Closure property, it means if you take sum or difference of a two complex number, it is also a complex number. This is called as the closure property. Okay. Second conditions, commutative law. Commutative, what is a commutative? Suppose that you have a complex number Z1 and Z2. If you write down just wanted Z1 plus Z2, it is also written in the form of Z2 plus Z1. This is called as the commutative property of in the case of the addition of a complex number. Next property is the associative property. Suppose that you have a three complex number. One is a Z1, second is a Z2, third is a Z3. Then you write down that Z1 plus Z2 in the bracket plus Z3, and that is equal to Z1 plus Z2 and plus Z3 into the bracket. Okay. Here first you take the sum of Z1 and Z2, and there you first take the sum of Z2 and Z3. This is called as the associative property of the complex number. After that, the existence of the additive property. Existence of the additive property, it means if you have a complex number and that complex number either you add by 0 or subtract by 0, so there is a no any change of that complex number. This is called as the additive existence of a complex number. Next, we are going for the multiplication of the two complex number. Suppose that you just wanted to take the multiplication of the two complex number. In the case of multiplication of the two complex number, if you just take that multiplication of two complex number, then I take the first complex number, that is a Z1, and this is equal to A plus IB, and second complex number Z2, that is equal to C plus ID. Then if you take the multiplication Z1 into Z2, that is equal to A plus IB and then C plus ID. You apply simple method for the multiplication. A multiply with C, this is the AC. A multiply with ID, that is equal to IAD. Then IB multiply C, then that is equal to IBC plus IB multiply this C ID, this is equal to I square B and D. This is the AC. You take I is common, so AD plus BC, and I square, that is equal to minus 1, then this is equal to BD. So the AC and minus BD, another bracket plus I, AD plus BC. Okay. So if you take the multiplication of two complex number that is written in the form of that is equal to a z1 into z2 that is equal to ac minus bd and plus I AD plus BC. One is the real parts, this is the real parts of the complex number and this is the imaginary parts of the complex number. Okay. After that we are going for the properties of the complex number. First we are talking about the closure property. Closure property, it means if you have a two complex number, one complex number is z1, another complex number is z2. If you take the multiplication of the both complex number, then you can find that z1 into z2, the resultant of that complex number, it is also a complex number. Here you see that one complex number is z1, another is complex number z2. Here we take the multiplication of z1 and z2 and we find that the resultant complex number that is equal to also a complex number. Next is a commutative property. In the case of the multiplication, commutative property, it means if you have two complex number z1 into z2, then you can write down that z2 into z1. It means first complex number multiply to second complex number, that is equal to second complex number, it is multiplied with the first complex number. Okay, this is called the commutative property. Second property is the associative property. Associative property, it means if you have a three complex number, if I have a three complex number, that is a z1, z2 and z3. So I multiply z2 z3, so that is z1 into z2, z1 and z2, then this is equal to z1 into z2 into z3. So we write down in that form. This is called as the associative property in the case of the multiplication. Next is the existence of the additive. It means the additive of multiplication, that is a 1. So if you multiply 1 with any complex number, so that is also equal to 1. Okay. So we are going to after explanation of these properties, we are going to solve some problems related to the complex number. So all of you see that are the some problems related to the complex number. Okay. First, question number first is that you see of the exercise 2.2. The question number first is that exercise 2.2, question number first of first, that you see first of first. Here simplify and express the result in the form of a plus ib. A plus ib you written in the form of, the question is 3 plus under root minus 16 minus 4 and minus under root minus 9. You express in the form of a plus ib. Okay, first we solve these questions. Here is a, you open the bracket, 3 plus under root, this is equal to minus 1 into 16. You can write down minus 16, that is a form minus 1 into 16, and minus, this is the 4, and minus it is a converted into the plus. This is also written in the form of here minus 1 into 9, the bracket is closed. Okay, so then this is a 3, 16, the square root of the 16, that is equal to 4, so it is a plus 4 and under root minus 1 and minus 4, the square root of 3, that is equal to 9, that is equal to 3 into here 4 minus 4 plus, that is a 3, and this is equal to under root minus 1. Then this is a 3 and minus 4, then you take that is equal to minus 1 and plus 4, this is the value of I, so 4i and plus 3i. Then this is the minus 1 plus 7i. This is the form of a plus ib. So you can say this complex number convert into the form of a plus ib. B. Okay, I think all of you understand. So we are solving next problem. Next problem is also you can express in the form of a plus ib. That is a question number 4. Question number 4 is a 4 plus I of whole square. You also written in the form of a plus ib. First squaring, apply the formula a plus b whole square. 4 4s are 16 plus 2 into 4 into I 2ab plus b square, it means I square. So this is a 16, 2 4s are 8i and I square, that is a minus 1. This is equal to minus 1. 16 minus 1, that is equal to 15 and plus 8i. So this is the expression of that complex number. This is equal to 15 plus 8i. Okay. Next question is also that question number 8. Here question number 8, that 1 plus 2i whole to the power minus 1. Then how you can return in the form of that a plus ib. So first I write down that this is equal to 1 upon 1 plus 2i, because that is a power minus 1. So it is goes into the denominator, convert into the power plus. So here I take the conjugate of that number. It means 1 minus 2i upon 1 minus 2i. This is the conjugate. So 1 minus 2i, that is equal to a square, 1 square minus b square, it means 2i square, that is equal to 1 minus 2i upon 1 square, that is a 1, minus 2 to the 4, I square. Therefore 1 minus 2i upon 1 minus and minus, because I square is equal to 4 into minus 1, that is equal to 1 minus 2i upon minus minus plus, that is a 5. So that is equal to 1 by 5 and minus 2 by 5i. This is also the form of a plus ib. So if you have a complex number, two complex number, it is given either in the form of addition, either in the form of subtraction, division, multiplication, inverse, or any other form. Then you can, after the solution, you can represent in the form of a plus ib. Okay. Next question number 2. Which of the following is in the form of a plus ib? Some complex number is given and you write down that these complex number are in the form of a plus ib. Okay. Question number 2. That here is a, suppose that question is given that 4th 6th number question, that 1 minus 3i to the power minus 3, and that we just wanted to denote in the form of a plus ib. So that is equal to 1 upon 1 minus 3i whole to the power 3, because there is a power is negative, so goes into the denominator, convert into the positive. 1 upon a cube, it means 1 cube minus 3a square b, 3a square b, it means 3i, plus 3ab square, 3ab square, it means 3i square, and minus b cube, it means 3i whole cube. Okay, according to the formula a minus b whole cube. 1 upon this is the 1 cube 1, 3, 1 square, it means 1, 3 3s are 9, so minus 9i. Here you see I square, that is equal to minus 1, so 3 3s are 9, 3s are 27, 27i square. Next minus 3 3s are 9, 3s are 27i cube. Okay. So next 1 upon 1 minus 9i 27 I square is equal to minus 1. So this is a minus 27. Here 27 I cube, it means I cube is equal to minus I. So this is a plus 27 I. Right? Then you see 1 upon this is the, you add with real part to the real parts. So it is a minus 27 plus 1 minus 26 and minus 9i plus 17, then you take that is a 18i. Okay, here after that you just wanted to, then you take 2 is common, so 1 upon 2 is common, so this is a minus 13 plus 9i. You multiply with the conjugate, then minus 13 and minus 9i upon this is equal to minus 13. Either you take the minus is common here, so it is easy for you. Here you take minus 2 is common, so this is equal to plus and that is equal to minus. After that you take the conjugate, so this is equal to 13 plus 9i and upon 13 minus 9i. Right? So 13 plus 9i upon minus 2 and bracket. 13 square it means 169, 9 square it means 81i square. 13 plus 9i divided by minus 2 and then 169i square, that is a minus 1 minus minus plus, so 169 plus 81. 13 plus 9i divided by minus 2 bracket, 9 plus 1 10, 6 8 14 1 15 1 1 2 250. So therefore that is equal to minus 13 upon 250 into 2, it means 500 and minus 9 upon 500i. So this is the representation of A and IB form. So it is a complex number in the form of A plus IB. You can solve as like this. Okay. Next question. Here the some questions are also given. It is also expressed in the form of IB. Third question number second, you also express in the form of A plus IB. A plus IB, then 1 minus I upon 1 plus I. Then how you can represent in the form of A plus IB? You take the conjugate or denominator 1 minus I upon 1 minus I. Then you see 1 minus I of whole square upon A square, 1 square minus I square. Then A square 1 minus 2AB, it means 2I plus B square, it means I square, and divide by 1 I square, it is equal to minus 1 minus minus plus 1, that is equal to 1, and this is the I square. So 1 minus 2I and minus 1 divide by 2. So 1 is cancelled by 1, this is a minus 2I upon 2, that is also cancelled, that is a minus I. So this is the form of A plus IB. Okay. Next some questions are also given. Find the real values of x and y for which. Suppose that you just wanted to real values of, find the values of x and y. Question number first, 1 minus I into x plus 1 plus I into y, that is equal to 1 minus 3i. Then how you can find the real values of x and y. You see, first you take imaginary part with imaginary parts and real part with the real part. So 1 into x, that is a x, minus ix plus y and plus iy, that is a 1 minus 3i. Then you take real part with the real part. These are the real parts. So it is a x plus y. And plus you take I is common, so this is a y minus x, because both are the imaginary part. 1 minus 3i. Comparing both sides with the real parts to real parts, imaginary part with the imaginary part. Comparing both sides of the equation. Then x plus y, this is the real part, that is equal to 1, equation number first, and minus x plus y, that is equal to minus 3, this is the imaginary parts. Okay. So after the comparison, here we take the comparison, then you solution of these, x cancel by x, so 2i, that is equal to 4, so y, that is equal to 2. So the value of y, that is equal to 2 from equation number first, that x plus y, that is equal to 1, the value of y, that is 2, so x plus 2, that is 1, x is equal to 1 minus 2, so x is equal to minus 1. So after comparison you can find the value of x and y. Similarly, you also solve other examples after the comparison, then you compare, then you can find the value of x and y. Next question, find the conjugate each of the following complex number. Then how you can find the conjugate of the complex number? Suppose that you have a complex number. Here, question number 7th of second, you have a complex number 1 plus 4 plus 3i, and you just wanted to find the conjugate. In the case of the conjugate, first you write down in the a plus ib form. So 1 upon 4 plus 3i into, you multiply with the conjugate of that number, this is equal to 4 plus 3i minus 3i, because you take the conjugate, 4 minus 3i. Okay, because before write the conjugate of any complex number, first you write down that conjugate number in the form of a plus ib. So here you see that a 4 minus 3i, here you see a square, it means 4 4s are 16, 3 3s are 9, minus 9i square. So this is 4 minus 3i upon 16 and minus 9i square minus 1. So 4 minus 3i upon 16, minus minus plus, so 16 plus 9, it is a 25. So that is equal to 4 upon 25 minus 3 upon 25i. If you just wanted to take the conjugate, so conjugate of that complex number, this is a 4 upon 25 minus here plus 3 upon 25i. This is the conjugate of that complex number. Okay. So all type of the problem related to that exercise may be completed. So I think all of you understand, and you can take the help of these various examples. You can solve all the other questions related to that exercise. Okay, thank you.